The type of object you now see on the video screen has traditionally been classified as a UFO, simply because of its shape. The idea of flying in such a vehicle has escaped aircraft designers since the term flying saucer was first coined in 1947. The unique shape alone of such an aircraft would compel ground-based viewers to gaze upward in astonishment simply because of the shape of the flying object. Surely such a craft would be in the skies today if it were actually possible. The novelty alone of such an aircraft would be tremendous. You literally could not fly the craft without catching the attention of anyone within sight of such an aircraft. The object you are now watching is such an aircraft. In fact, according to the United States Patent Office, there is no other aircraft like it in the history of American aviation. As you will see, this design is surprisingly stable and maneuverable throughout the speed envelope. But most important, it is stable at very slow speeds. Preliminary designs are now underway for a two-passenger craft with the same aerobatic qualities you now see in the prototype. A static model of the full-scale version appears at the end of the video. Now, in case you haven't spent the last few years experimenting with circular airfoils, a brief explanation about why this design succeeds where others have failed might be helpful. First of all, the same technology that allows a typical small two-passenger fixed-wing aircraft to fly will also propel a full-scale version of this prototype you are now watching. Beyond that, the aircraft you now see is like no other before it, mainly because it is a forward-biased design contained within a peripherally symmetrical shape. The entire wing consists of three different shaped wings which combine to form a peripherally circular form. The three wing shapes are a forward wing, a rear wing, and two wing tip sections that connect the forward and rear wings together. The term forward bias simply means that the forward half of the airfoil has more lift than the rear half. This places most of the lift about the center of gravity of the aircraft, instead of directly behind the center of gravity as in previous designs. This allows the aircraft to fly at very slow speeds without stalling. Furthermore, a unique aileron configuration allows for an amazing amount of control at such slow speeds. Unique because there are actually two sets of ailerons. The forward ailerons, which are located about the interior trailing edges of the forward wing, and the rear ailerons, which are located about the trailing edges of the wingtips, thereby maximizing the amount of air deflection possible. Another important design feature is that the power plant is centrally located, which allows for a continuous circular edge. Prior experience indicates that this has an immediate effect upon the uninitiated viewer. At first glance, they see a circular aircraft that appears to have no means of propulsion. During test flights, responses ranged from passing motorists who came to a screeching halt to whole neighborhoods lining the streets to get a glimpse of something very unusual. One can only imagine what will happen when the first full-scale, three-wing, circular, planform body takes flight.